Hey everyone, welcome back to Bugnojutsu. In today's video, we're going to solve a very interesting LeetCode problem called Zero-Filled Subarray. At first glance, it looks simple because it only deals with arrays and zeros, but once you start thinking about subarrays, things can get tricky. Don't worry, in this video, I'll walk you through the problem step by step, explain it with examples, and share my own clean and intuitive method that will help you crack it easily. The problem is as follows: you are given an array of integers, and you need to find the total number of subarrays that are made up entirely of zeros. Now, remember, a subarray means it must be contiguous, the elements have to be next to each other in sequence. So if you have an array where some parts contain only zeros, every possible contiguous group inside that block of zeros counts as a valid subarray. And the challenge is to count all of them, no matter how long or short they are. In this example, the array is 1, 3, 0, 0, 2, 0, 0, 4. Here, we have two separate streaks of consecutive zeros. The first streak is 0, 0, between 3 and 2, and the second streak is 0, 0, between 2 and 4. Each of these streaks contributes subarrays. For a streak of length 2, we get two single-element subarrays, 0, 0, and one two-element subarray, 0, 0, making 3 subarrays in total per streak. Since we have two such streaks, that gives us 3 plus 3 is equal to 6. That's why the output is 6. Now let's talk about how to solve it in a clean way. Instead of trying to generate every subarray one by one, which would be inefficient, we look for consecutive streaks of zeros. Here's the idea: we scan the array from left to right and keep a counter to track how many zeros are in the current streak. Every time we see a zero, we increase the counter. When we see a non-zero, we stop and calculate how many subarrays were formed in that streak. The formula is simple: if a streak has length k, the number of subarrays inside it is k times k plus 1, divided by 2. So if the streak was 3 zeros long, that gives 6 subarrays, just like in our earlier example. After counting, we reset the counter and continue with the rest of the array. At the end, if the array finishes with zeros, we apply the same formula once more to capture the last streak. This method is clean because it only requires one pass through the array, and we only store two variables, the counter and the result. In terms of complexity, the time complexity is O(n), because we're scanning the array once and doing constant time calculations. The space complexity is O(1), since we only use a couple of variables regardless of input size. That makes the approach very efficient, even for large arrays. The key insight here is that instead of brute forcing all possible subarrays, which would be very costly, we can leverage the structure of consecutive zeros. Each streak of zeros behaves in a predictable way, and the formula k times k plus 1, divided by 2 captures all the possible subarrays in one shot. This is a common trick in array problems, grouping elements into meaningful chunks and handling them smartly rather than individually. And that's it. We've successfully broken down the zero-filled subarray problem and solved it in a simple and efficient way. If you enjoyed this explanation and learned something new, make sure to hit the like button and subscribe to Bugnojutsu for more problem-solving breakdowns and insights. I upload regular videos where I take complex problems and simplify them for you, so you don't just solve them, but also understand the intuition behind them. Thanks for watching, and I'll see you in the next one.